All right, well, I think we'll go ahead and get started. Welcome, everyone. We're very excited to have Carolyn Rosé here to speak with us about the next frontier of AI-enabled collaborative learning. I just wanted to let everyone who's joining know that this is a session sponsored by NYU-LEARN, the Learning Analytics Research Network at NYU. We're working in many different ways to build the future of data-informed teaching and learning research at NYU. In case you missed any of the other great events we had this semester, Roberto Maldonado talking about multimodal data stories, Yoav and myself talking about the results of our College in the Time of Corona spring survey, and an interactive workshop we ran on what data would make you change your course. You can go to the link at the top, and Suzanne, if you can drop that one in the chat as well, please, to review recording and slides of all of the prior events. And if you have ideas for events you would like in the future, we're inviting suggestions for what learning analytics speakers you'd like to hear from most in the spring. The link is already in the chat and on the slides, and feel free to suggest names of people you think would have lots of exciting ideas and research to share with us. Finally, if you want to learn more about what we're doing at NYU-LEARN, the different projects we have ongoing and the ones that we have coming up, please visit our website where we have lots of great information for you. And now, without further ado, I am very pleased to introduce Carolyn Rosé. We wanted to have her here in person with us in the spring, but as the world changed, we are very happy to be having her with us in this format as well. She's going to be speaking about the next frontier of AI-enabled collaborative learning, talking about both work in the classroom and I think looking eventually towards the workplace. Carolyn is the professor of language technologies and human-computer interaction at Carnegie Mellon University in the School of Computer Science. Her research program focuses on computational modeling of discourse to enable scientific understanding of the social and pragmatic nature of conversational interaction of all forms, and using this understanding to build intelligent computational systems for improving collaborative interactions. In short, she's using really exciting technologies to study how people collaborate with and through technology, and building really exciting tools to help them do so better, leveraging the power of natural language processing and AI. Her work and her team's work has always impressive and been published in top journals in all the different fields, from learning technologies to learning sciences to cognitive science to educational technology and human-computer interaction. She's a past president and inaugural fellow of the International Society of the Learning Sciences, a senior member of IEEE, one of the founding chairs of the International Alliance to Advanced Learning in the Digital Era, IALD, our latest acronym, and has also served as a 2020 to 2021 AAAS fellow under the Lesher Institute for Public Engagement. In short, she's doing tons of interesting work, and we're very pleased to have her here to share this work with us today. So please give her a warm welcome. Thank you so much, Carolyn.
Hi, okay, great. I am going to share my screen and pull up my slides. Okay, so I am going to cover sort of a combination of some of our older work and some of our more recent work in order to kind of tell a story about what is the motivation for some of the questions that we're working on now, and how does that suggest directions in artificial intelligence research that might be valuable in the field. And as I look out on the audience, I see some of our recent colleagues from OLU, and I'm going to mention some of our joint work. And I also see other people very far into the field of learning analytics, even in collaborative learning, for whom a lot of what I'm going to say is not going to be strikingly new because A, you've known me for a long time, and because you're also doing related work. But I wanted this to be very generally accessible to the audience regardless. So think of it as a story that I'm telling you, and then engage with me in the story, and let's talk during the question time. I do want to point out that I'm co-editor-in-chief of the International Journal of Computer-Supported Collaborative Learning, and so I'm really representing the area of collaborative learning here, and I'd like to encourage you to engage with our journal, both in terms of submitting to it and reading recent editions. Okay, so for about 15 years now, I've been doing work in using conversational agents to support collaborative learning, and this is one of our early interfaces. This was for sophomore college level thermodynamics, where students were working together to design power plants. But before that time, before I started to work in collaborative learning, I was doing work in tutorial dialogue. And I came from a computer science background where I worked with people who weren't really very grounded in learning sciences from the human side. And from them, I learned as an undergrad to have this expectation that it was all about the technology. And I thought, I'm going to go off and fix the one big technology problem that keeps tutorial dialogue agents from being good teachers. And I'm going to change the world and improve education. And I found out during my postdoc years, when I finally got to really work in the area of tutorial dialogue, how naive that idea was and how important it was to understand what is it that humans need out of the process in order to learn. And I became very discouraged as I was working on the AI to support, to create agents for teaching individual students, because what I realized was you can never really replicate the richness of human interaction with an agent, not because it's impossible to do the AI, but because no one will talk to it that way, even if it's capable of having those interactions, because there's no human mind there. There's no reason to reach out and try to build common ground. It isn't a person that you can get to know, and people know that. And so then I really turned my attention 15 years ago, approximately, to using the technology as a catalyst between humans to try to get more richness out of their interaction with each other. So this study from 2007, I consider on the one hand a successful study, because what we saw there is that when students are paired with another human student and with an agent, they get about 1 letter grade improvement from the individual interaction they have with each. But when you put it together, there's the synergistic effect. It's not like the support that they offer is redundant. They gain more from having both than from either of them individually. It's not like twice. So it's not like totally different support that they're getting. There is some overlap, but there must be something different in what they gain from the scaffolding of their reasoning that a conversational dialogue agent can lead them through. But there's something different that they get from the human-human interaction with another student, even though that student doesn't know everything, can't, perfectly scaffold their reasoning, but engages them from another direction. And so since that time, we have worked in a variety of different areas of learning with a similar paradigm, where students are working together in a distributed fashion, each of which has their own client interface on their computer, and they're interacting with the other student through chat. There are computer agents in the chat facilitating the conversation, trying to deepen the conceptual depth of the conversation. And meanwhile, there's also shared workspaces where they might be doing math problems, or they might be writing an essay together, or they might be comparing their analyses from work in a simulation environment. Most recently, we have moved this into kind of the 3D face-to-face realm. And you can see here a link to a video, which I'm not going to play for you now, but if you want to see it, you can find it. You can search on the Vimeo site for the CMU LTI space. And if you look for a collaboration smart office space, you can find the video, or I think this link, well, I gave my slides to the people who organized this, so you should be able to get those if you wanted and look at it later. But here you can see it looks different on the surface from our other collaboration studies, because it's not like people are sitting alone at their own screen interacting through chat. They can talk to each other, they can move around the room, they can write on the whiteboard, and the conversational agent isn't in a chat space. It's on that screen in the back of the room. It can look at who it's talking to, and it can tell where the students are in relation to one another. And in particular, in this setting, you'll notice the students are wearing masks. And on the one hand, it's working to deepen the depth of the conversation, but at the same time watching to make sure that doesn't mean that the students are getting too close, because they're in this physical space where they have to keep their distance now. And so how do we balance this idea of social distancing with the idea of still wanting to engage people in intensive interaction together? So what all of these settings have in common, at least all of the places where we have been developing this support for collaboration, is the idea that the support that we offer is context sensitive and interactive. So we want to be able to monitor the interaction between students in real time. And that's important because we don't want to construct the super complicated agent that can control the whole richness of the space of how a pair of students might interact with each other. Instead, what we do is we let the students direct their interaction with one another, and we look for opportunities to come in. And so what we can do is coordinate a number of simple agents to come in at the appropriate time, so that when you look from the outside at the whole orchestrated interaction, it looks like a very complicated agent with a strategy. But it's really a lot of decentralized, small, much less complicated agents that are triggered by these listeners that are always monitoring the interaction in real time. And so if you know the intelligent tutoring literature, it works very much like a constraint-based tutoring system and has a lot of the same advantages of that. And I would say that it's, you know, an important part of our approach overall. So in our research, we have worked to develop an infrastructure that allows us to do the development of new designs very quickly, because what we don't want is to spend most of our time being technology people. We want to spend most of our time understanding what the pedagogy has to be, developing the good pedagogy, understanding more about the processes, and spending very little time building new systems. And so we do that by having a very data-driven process where a lot of the technology time that we spend is actually in modeling the interaction data. But in doing that modeling, then we have the ability to view what's happening in our data, but also to use it to enable us very quickly to be able to build these systems that can monitor the collaboration in real time. The idea is that these agents are serving the purpose of scaffolding. What they're scaffolding is the conversational processes. And we have to understand the connection between conversational processes that we can see and learning processes that we can't necessarily see. But these processes have to be in place and they have to be functioning well in order for the learning to be happening as well as we like. Now, we've been investigating the design of agents to serve this purpose over these 15 years, and we've done it across lots of different contexts that you can divide using different dimensions. So we've done middle school, high school, college. We've done urban school districts versus more affluent school districts, top tier universities versus second tier versus community colleges. We've looked at math, science, engineering, and the social sciences, and we've done some work in the massive open online course space. And across all of these, we've worked over these years to develop design principles. And all of these principles that you see here highlighted in green, we've got papers, often multiple papers, investigating these principles in multiple contexts. And they don't all work the same way across all contexts. And so a lot of the work that we have done is on trying to identify how would you pick one? We have successes on all of them. It doesn't mean that they would all be successful in all cases. Sometimes scaffolding that works really nicely in one place gets in the way in another place and reduces learning. And so what we've learned to do over the years is to be able to come to a new setting and look at the processes and see what is getting in the way and which of our designs might address the problem in this particular space, because we don't want to select some of our scaffolding that's meant to address a particular problem that's not the problem that they're having. That means that when we go into a new setting, it takes some time before we will see success. And I'm going to talk about some of our more recent work in the collaborative software development space. And that's where we start to get into this idea that right now, what we're really excited about is moving into learning in the workplace. And we want to be able to support learning in software teams, and specifically in the area of cloud computing, because we have a long-time partnership with somebody who not only teaches in universities, but also has courses in community colleges. And so we can look at all different levels within this space and also think about how people learning to learn in these collaborative software development spaces will continue to use those collaborative software development spaces as they move into the workplace. Can we continue to support their learning there? So we have a large focus on conversational processes, and that's where my language technology side comes in. And in all of my work in language technologies, I'm very interested in how conversation works from a language perspective in a way that's kind of considered passé in a way in my field, because computational linguistics used to be much more about language, less about machine learning. And it's really changed over in the past couple of decades, but it is coming back around. So I've never lost my passion for understanding the interaction from the language perspective per se. And a theme in a lot of the work that we have done on modeling conversational interactions is to think about a process that, well, under one of its names is referred to as transactivity. If you look across lots of coding schemes for picking out what's valuable in collaborative discourse, they often have a dimension that is very similar to transactivity, even if it's called something different. And essentially it has the same two preconditions. One is that people are articulating their reasoning. And so this shows up sometimes in the level of how much elaboration, but also in showing an underlying mechanism. They're explaining how they think things work. So it doesn't even have to be long. It could just be that there's some causal mechanism that's being expressed in what they're saying. So they're making an attempt to show their reasoning, and they're connecting it to the reasoning of others. Here's an example from a series of studies that we have done where students are working together, not on the design of a power plant, but a power plan. They're looking at how cities can use combinations of technologies to provide the power that the city needs, and how trade-offs are different across cities depending upon lots of different factors. And so students in these studies where we focused on these environmental issues adopt different perspectives on these power sources and negotiate with one another. And here you see a student is expressing a position, and a transactive reply would have the two conditions that I mentioned. The first two replies are oriented, they are a response to the first reply, but they don't express reasoning. They don't reveal what these speakers are constructing in their own minds about how power plans play out in cities, whereas this last student does. And we want to see both aspects. And part of it is because what that says about that student's orientation towards the group, that they're open towards other perspectives, that they're interested in other perspectives, but also that they feel safe enough to be open. They're exposing themselves because they're willing to engage with the idea that they might not be correct. And in getting that balance into the interaction, they have the opportunity to do a comparison between how they think and how they're seeing other people think. And in doing that comparison, that active comparison in that open state, they're able to experience that maybe there's another idea that they can let in and experience that reorganization of their knowledge. So in different theoretical frameworks, it might be referred to under different names, but ultimately all of our designs are focused on trying to foster this. And there are lots of different levers that can be pressed in order to affect this. You can try to create more of a sense of safety. You can try to highlight what's different in somebody else's perspective. You can try to get people to stop and say more, just so that you can try to get that elaboration out in hopes that that means that you'll get that causal mechanism out. And so even if our designs look different, they're all aimed at getting at the core of this kind of exchange. And there might be other conversational processes around this one that support it, if we understand how it works. So at its core, it's about building a shared understanding, that it's predicated on deep listening, comparing of mentor models, and sharing of insights. And that underlyingly has respect and interest and self-efficacy. And we see in studies of our own and in the literature effects on learning, expertise transfer, and group task success. But in our recent work in the medical area, we are also exploring the extent to which this property in doctor-patient interactions may lead to an experience of shared decision-making on the part of the patient. Digging back in time to around 2012, we were modeling language in collaborative settings in speech based on how it sounded. And it's hard in a group to get accurate enough speech recognition that we could do the model of transactivity monitoring that we would normally do in chat or in discussion forums. And so we wondered, well, what would we do in this case? And this is where we see evidence that this idea of these layers that I just presented about what is it that is underlying this transactivity, and why is it that we think it actually does connect up with learning? Is it about the ideas actually being expressed together, or is there something else? What we were looking at here was what in sociolinguistics is referred to as accommodation, speech style accommodation. And there are circumstances under which you expect to see that happening in an interaction. And it could be a signal that people are trying to build that common ground with another person. And so if we can measure speech style accommodation in the pronunciation of vowels within an interaction between students who, these were undergrads, so they could be coming from all different parts of the country, and they might, have a regional dialect that, has certain stereotypes associated with it. There's all kinds of reasons why seeing speech style accommodation might be associated with trying to build a common ground with somebody else. So we hypothesized that if we could measure it, and we built this BayesNet model that allowed us to build connections between variables within what we could extract from the speech that represent comparisons between one person's style at a time point and another person's style at that time point, but also how the sequence of styles within one particular student in the group might change over time. In building together within the structure of the network, the appropriate comparisons to identify trends that over time took on the shape that you would expect if people were accommodating to one another, we were able to measure the extent of the speech style accommodation. And then we hypothesized that we would then see where there was higher evidence of speech style accommodation from the network, that there was more transactivity being exchanged. And we did see a correlation, a significant correlation. And our value of 0.4 is not high enough to say this is a measure of transactivity from speech, but it is something that says there's really something there in the signal from the speech style correlation, speech style accommodation that's connected to the transactivity. And so you can see that it is a confirmation of this idea that there's something social going on that's underlying the exchange at the cognitive level. And so then we turned it on its ear and said, if it's true that you can see evidence of the social underpinnings when you see transactivity and vice versa, that from those social underpinnings, you can predict the transactivity. Maybe if you can measure the transactivity from what people are saying, that might tell you something about the social interaction between them. That if you see them behaving transactively, that might mean that they have respect for one another, that they're interested in one another. And maybe you can use that as a signal for collaboration potential. And so then we did a series of studies that were meant to be embedded in a massive open online course. And we did indeed evaluate this paradigm within a real massive open online course run through the Smithsonian Institute, where what we did was we had students do individual work, then they would post that to a discussion forum. Anyone in the class could respond to them and give feedback. We could then do an automated analysis of the discussion forum to measure pairwise transactivity across the class, and then use that pairwise transactivity measure as an estimate of collaboration potential. Then we could use an approximate constraint satisfaction algorithm to search for a way of taking that class and breaking it into groups of 4 so that people were more likely to be with the people who they had a high collaboration potential with. And so we did a study. Well, the quantitative study we did was actually in simulated classes in Mechanical Turk, where we could have like lots of different classes over a short period of time, where in some classes we would use this transactivity maximization to do the team assignment, and in other classes it was random. It wasn't exactly random. There were other constraints that occurred in both conditions to make sure that all perspectives were represented within groups equally, regardless of condition. But we wanted to see what is the contribution of using this signal of collaboration potential. And what we found in that quantitative study, we looked for success in terms of evidence of knowledge integration, both in the chat processes that occurred during the collaboration and in the product that was produced. And we saw significant positive effects on both. And then we took this and we evaluated it in the context of a MOOC where, since it was only one MOOC, we used the transactivity maximization for the whole class, but we looked for correlational evidence that we saw a consistent pattern, and it was consistent. So overall, what that shows is why, one reason why these conversational processes are important, what they signal, how we can monitor them, how we apply in our monitoring our understanding of why we would see some features being predictive or not. We want to understand these things not as pieces of data and machine learning models, but as indicators of something that's going on socially, cognitively, from a learning perspective, from a relational perspective. It's all coming together in these settings. So we're extremely interested in the idea of how this might influence learning for workforce development and ultimately learning in the workplace after people have been trained. And so in these past few years, I have been working with my colleagues that you see here, Maj Saker and Michael Hilton, on learning in collaborative software development. One challenge, which I'll just highlight, is it took us years to get the learning objectives for advanced programming defined well enough that we had tests that could measure learning in a way that would tell us if our interventions were even working. That might not sound like it should be hard, and I guess if this is a school of education, you're laughing at me. But there hasn't been a lot of research in learning sciences in advanced programming. There's been a lot at elementary programming, where I think that the learning objectives have been very, divided into bite-sized chunks, and you kind of know what every assignment is about. But in a class like cloud computing, the students learn a programming language, and then they develop, some cloud application using tools, and they're supposed to be learning how to use, Spark or whatever. And it's like, well, what does that really mean? Can you actually measure on a test the learning that you think that they actually managed to have the opportunity to do in their activity with each other during one class period where they were, doing some activity in this space? So it is actually very challenging. And we finally, after, lots of rounds, have gotten units of this course mapped out well enough that we can run meaningful studies. And now what we're doing is really investigating how the learning in collaborative software development can be supported. And we're leveraging a paradigm from industry referred to as mob programming. I know that sounds awful. It's kind of, we would say, it's like pair programming on steroids. Pair programming, I think, is a term that's much more well known. There have been a lot of studies in learning of elementary computer science that use pair programming. I was skeptical of mob programming at first, but lots of companies swear by it. And the idea is that you have a group of developers sitting around a table, and they have different roles. Only one person is actually typing code. And the other roles are weighing in one way or another, either guiding the direction that the coding will take, or bringing in alternative perspectives, evaluating the work that's being done. There's a lot that underlies mob programming that sounds a lot like what we tried to achieve in collaborative learning. And so when I heard about it from my colleague, Michael Hilton, who did some research on this in his PhD in the field of software engineering, I thought this is an awesome opportunity to be able to start to explore these issues of collaborative learning in collaborative software development. And that's when we started to work on this. And so what we're doing is developing an online place where we can instrument the system to monitor how students are engaging in mob programming practices in their collaborative software development. So we started out in AWS Cloud9, And now we're moving into VS Code Live Share, which is a Microsoft version of this. It's actually nicer. But in either way, students are able to collaboratively work on software development. There's a chat space, and we have our conversational agent orchestrating this activity, monitoring how students are engaging in the activity, telling them what role that they should play and then when they should rotate, guiding them to engage more reflectively as they think about alternative solutions. And so we can apply a lot of the design work that we've done in the past and see how it contributes. But the question is then, okay, how would we bring this into the workplace? Well, in one way, there is a lot of work that happens in the workplace using these collaborative code development environments now. But there is a large extent to which the learning and the interaction and the collaboration happens throughout the organization, around the water cooler or the coffee machine at lunchtime, standing in the hallway, or at meetings where people are face-to-face. Now, we've all recently experienced a shift in our lives where all of a sudden we were moved to having to shift our instructional practices online, even if we hadn't been doing our teaching that way in the past. And so we've seen, I think that this just causes us to reflect a lot on the assumptions that we have put into our teaching and into our research, and just causing us to think about online learning principles in a different way. And in my mind, these questions about workplace learning and how it occurs in physical spaces often connects up also with concerns that I think about when I think about students moving back into the classroom, and how it is that even if they're there, even if the hoped for social interaction they've been missing at home might seem like it's close at hand, there's this worry that in observing the safety practices that have to be in place and probably still need to be in place for at least another year, even though there's a good hope of a vaccine soon. What will happen to using collaborative learning in classrooms if kids have to stay in their little circle? And so we come back to this work that we have been starting to do even before COVID-19 on learning in physical spaces, or being able to bring our collaborative support designs into collaboration face-to-face. And we've been collaborating also with Sana Yarvala's work in a group in Oulu, and they have this amazing instrumented space where they have collected a large data set, which they have annotated with categories that are relevant for their work on analysis of socially shared regulation. And we want to identify what are those modeling questions that we have to address to be able to offer support, in her case, for socially shared regulation in physical spaces. And from our standpoint, focusing a lot more on transactivity, just because that is a trend in our research. And so we've got sensor data coming from different streams. It has to be coordinated, it has to be integrated, and we have to address some important questions and problems, some of which have benchmark tasks in technology areas that that don't exactly stretch over into these exactly what we need them to be in order to apply them to these problems. And so there's an important adaptation that needs to happen of models trained on large benchmark data sets from AI fields like, active speaker detection or diarization or any of these kinds of face recognition that you probably have heard lots of hype, I'm sorry to say, about major advances that have taken place so far. But those benchmark data sets, they make assumptions that just don't hold when you look at a setting like Sana's instrumented classroom or our smart office space. You can find out more of the technical details about what we've done in our smart office space and how we've done the synchronizing of the separate streams, bringing them together and connecting them up with our architecture so that we can have listeners, not just of chat in real time, but of all these streams coming together in real time that give us signals about how people are collaborating, both in terms of their knowledge integration and their physical space positioning within a space. And so, of course, this requires the introduction of specific kinds of sensors. But what's really important is about how we take that sensor data, where from each of these streams, the time scale is also very different, getting them aligned, getting them divided into chunks that go together. All of that work is not trivial. And yeah, anyone who's done that kind of work knows that there are lots of technical challenges there. And it took months to get it to work right. And it seemed like it should have been so simple. But in any case, you can hear about some of our specific challenges. I want to acknowledge my colleagues at Microsoft for the Platform for Situated Intelligence, which is a module that allows some of that synchronization to take place effectively and efficiently. And I would highly recommend it. And we talk about how we use it in that paper that I referred to earlier. And this allows us to be able to bring the support into the physical space so that we are delivering the scaffolding with an agent that's there, having some physical presence in the room and being able to gesture to people. But that also raises questions about how that acts as a catalyst. And we have questions about whether the designs that we have developed and that have worked in chat will work the same way in these physical spaces. And so currently we actually have a Chinese version of our smart office space, and a student from Yan Li's group at Beijing Normal University spent a year in my group and went back, and now he's about to run the first study comparing using the same bizarre architecture, that's our dialogue architecture, but in the physical face-to-face collaboration versus online collaboration, but same support strategy. Does it play out differently when the agent has this physical presence in the room? And you might say, well, why would it be different? Well, because it could distract the students from each other. Because in the chat, if the agent is saying something and they want to talk to each other, it's very easy to ignore the agent. It might be less easy to ignore the agent, or it might not always be that you might ignore it more because it isn't on your screen. So we have to kind of see, how is attention managed? How does that affect how this catalyst works? But ultimately, by bringing the capability of using the same support either into a face-to-face setting or online, allows us to think about this important question of how we can actually continue to support learning as people take it out of their formal workforce training and go back into the workplace. And so we're working on using our infrastructure as a kind of in-between space where we can collaborate with our industry partners. We just had a great meeting today with PNC, who were working together, will be working together on a series of these studies to be able to find scenarios that are workplace relevant, that represent the real challenges that we have to face in those settings, but to be able to learn how to actually face them without interfering with somebody's work, so that once we have the findings, then we can take it into the workplace for deployment studies. So that's kind of a broad overview. I'm going to look forward to hearing your questions during the question time. Basically, what I've done is given you an overview of some of the technical work we've done, why we've done it, some of the studies that we've run and where we're at, and what are the big questions we're asking. And I would be very happy to entertain any questions that you might have.
Well, that's a lot, Carolyn. I think everybody's minds are reeling with all the different possibilities to think about. If you want to go ahead and stop sharing your screen, I think we all want to first say thank you. That was a really exciting talk, and you can see the various clap icons. We're running this as a Zoom meeting, not a webinar, so to hopefully make the conversation part a little more engaging than that version we all have, where everyone feels like they're at the end of a long tunnel. So no obligation, but if anyone is willing to put your camera on, we can all come here and chat. If you want to say something, go ahead and use the hand raise tool. I forgot put my video on as well here. We'll do the hand raise tool, and I'm going to start off with a couple of questions that came in the chat during the talk itself. So Any of the people who asked their questions are welcome to speak, but let me start off by trying to sort of set the stage, because I think all the questions asked so far have a very similar theme, and they have to do with context. And you sort of said early on that, you know, one of the things you want to be able to do is come into a new situation, look at all the things going on, and realize quite quickly what kinds of solutions are going to work best. And so I think people are interested in knowing more about what are the different factors that help you realize what kinds of collaborative supports, agents, or others are going to be most effective. So specifically, I'll start off with a couple of questions asked by Zikai Alex One, who also has his hand up, so I'll let him elaborate. But he was asking about the difference between verbal and text-based conversations, synchronous and asynchronous, and whether you've ever done any work with special ed students and the special conditions. If you want to elaborate on those questions, feel free.
Okay, so the last one is easy. I have never done any work with special ed students. I think it is a really important area. I think it's an increasingly important area as there's far more interest in more and more mainstreaming. And so I would love to have the opportunity to do that work in the future, but I just haven't. And I strongly suspect that there would be lots of issues that I would have to address, things that I'd have to do differently than I have in my past work. But in terms of text versus, I think it was text versus speech and synchronous versus asynchronous, these are contrasts that we have investigated. But I have seen, I do have a journal article with Diane Littman where we were looking at speech versus text in tutorial dialogue, and we didn't actually see a lot of difference in that. And even to the extent that you would expect, and we did see that when you're using speech, that the recognition, there's more language recognition errors than there would be if you were doing text. And somehow the fact that the accuracy was less good with the speech didn't seem harmful. But the fact that it was easier for people to communicate in speech than in text also didn't seem as helpful as you would expect. So we didn't see huge differences. And we haven't done speech versus text on collaboration. When we were setting up our studies for the cloud computing, the collaborative software development, we actually experimented with a lot of different ways that people might communicate with each other. Would it be good to have video? Would it be good to have audio? Would it be good to have chat? We actually found that when they were in that collaborative software development environment, that the text-based interaction worked best. It felt less clunky, even though that's not what you would have anticipated. We really didn't pick the text in that case out of convenience for ourselves. We tried, because before we ever even introduced any automated monitoring, we did time after time after time of pilot session where we tried it in different ways to see what would be most natural. And actually the text-based interaction there worked better, but we didn't publish a paper about that. Now on the 3D, well, so synchronous versus asynchronous, I do think that's extremely different. I don't think any of our designs for agent support generalized to asynchronous. They're all very much focused on the synchronous aspect of the interaction because what they're trying to do is get attention at a moment where there's something in particular to pay attention to and respond to, and that's just not how asynchronous works. Asynchronous is more, you could call it random access, even if it's not random, because you can always go back and reply to something from a really long time ago. And you can take the time to really sit and reflect. You can read and think about something longer and formulate your reply. And so all of the things that we have developed that support synchronous interaction are solving a different problem than the problem that you would have in an asynchronous space. We have developed support in asynchronous spaces in our work in MOOCs, but we haven't done nearly as much of that, and I'm less interested in that. So I don't have as much to say about that question, but I do believe it's very different. As we're thinking about moving the learning across contexts, so thinking about chat-based versus the face-to-face in a physical space, it's synchronous in both cases. And in one case, it's text, and in the other case, it's speech. But we don't actually think that the speech versus text is the most important difference there. I think that the most important difference is that when you're in this physical space, you can move around. There is a lot more to pay attention to. So what would it mean to manage attention effectively? Basically, what we're doing is an attention management issue. It's about like, what should we be focusing on right now, and how should we be engaging with that thing? And if there's more to pay attention to in a room when you're moving around, maybe you could still find a strategy that gets people to focus narrowly on the same things you would have gotten them to focus narrowly on in the chat. But what's not clear is whether accomplishing that is the most important thing to happen in that space. And so I think we actually don't know the answer yet. And so this one study that we're about to run in China will just be a first study where we start to get our feet wet and start to get more aware of the issues. But I think one of the things that will be an issue is about how much presence in the conversation the agent has. Because what we have seen in some of our failed agent designs from past studies, and not all of our failures have been published, but we know what they are, they were places where the agent got in the way, that it interfered with the collaboration. It might have motivated people to be more engaged in the task, but less engaged with each other. And then they benefited less from the collaboration, but the collaboration being there still incurred some process losses. And so then the overall, was it valuable to even do it collaboratively? Maybe not under those circumstances. So I think there are a lot of questions here, and I definitely would never trivialize this idea of making learning general across contexts. I think it's a whole research agenda. And so in a way, this is like my position paper. I'm saying, I think we really need to think about what are those dimensions and what are those questions. And but from a technical perspective, I would say one thing that we are working on that I think contributes towards this is using a reinforcement learning augmentation of our architecture to build in the adaptation process. If the system can be aware through its monitoring of whether what it's doing is working, it can learn through its experience to develop strategies that fit a context better. And so my student Sri Charan is working on that. He has had some recent success. I think there are still a lot of questions to answer. So that might have been a longer answer than you were looking for. So I'll turn the floor back to questions.
That was a great answer. So I was going to originally have people ask their questions, but given the time, I'm actually going to just ask if Zakai has any follow-up on that, and then I'm going to synthesize two other questions and give them to you together.
I just want to add on to that. So you didn't see the difference between text and verbal, but I'm working with students with learning disabilities, there's a huge difference. So I just want to add on to that. So my current work is basically saying that there's technical designs that can actually contribute to our current models to make it more accessible for students with special needs.
Yeah, that's extremely interesting. And I hope I have the opportunity to work on that someday. I really do.
Great. Thanks for those questions, Zakai. Also, I think implicit in what you were saying, Carolyn, about the speech not mattering and about physical space, I'm starting to wonder now if Zoom is closer to chat than being in a physical space with people by that sort of analysis, which is interesting food for thought. Let me pull together two questions. One is from Samin, who is asking about, I think, whether you're seeing these conversational agents as sort of an ongoing scaffold or something that eventually would be faded. In other words, was the support of the agents, would it make students more able to carry out transactive dialogue on their own? And I'm going to combine that with a question from Peter about, in mob programming, the code is often as important as the speech. And is there any way to support the CSCL by adding code analysis? And then I would ask is that something that you would want to have as ongoing support, or something you could imagine that would enable them more able to monitor the code and interact better on their own eventually?
Okay, so on the code question, we're also working on that because there's work in the field of software engineering on modeling coding for using deep learning for the purpose of either automated bug fixes or suggestions of code additions or just helping with troubleshooting. And so what we'd like to be able to do is offer some hints related to the programming inline. And so we've been working with Joseph J. Williams' group on a collaborative project for automated hint generation for programming. And we'd like to be able to test that out, hopefully in the next year in one of our studies in cloud computing. That I think, would we fade it over time? I think what would end up happening with the way we plan to use that is, to the extent that what it does is process a program that it's seeing you write in real time and give a suggestion, that it should adapt as your code adapts, because it would be responding to the code that you're writing. And if you learned something from the earlier coding experience with feedback, you would write different code. And so then you would get different feedback. So it sort of has this natural progression built in, but we'll have to see if it really works that way. That's the idea. And that's just early work. I think that from the very beginning of my involvement in computer-supported collaborative learning, it all started with a collaboration with Frank Fisher, and it was always with the idea that scaffolding for collaboration should be faded over time, because the hope is that students are internalizing the script and that they don't need it as much later, and that continuing to scaffold the interaction could be demotivating. But I will say that I have never actually observed in any of our studies, perhaps because they don't go on long enough, that we get to a place where it's actually better to fade the scaffolding. But we do believe that we would get to that place. One thing I have seen, so one of my students, Xu Wang, she's just about to start as a professor in Michigan, so I'm proud of her. She did a study where she was comparing implicit support with explicit support, so for transactivity. So the explicit support was about prompting, and the implicit support was just using our transactivity-based grouping to put people in teams where we thought that they would speak more transactively with each other anyway. And what we found was, in both cases, the amount of transactivity exchanged in the group was elevated, so that the implicit support for transactivity could be just as effective at increasing transactivity during the collaboration. But what it doesn't do is it doesn't serve a norm setting function. We saw that there's actually an extent to which the explicit prompting serves as an instruction of what's expected, so that people come away with more of an awareness that that's the kind of interaction that's desirable. Whereas they might experience that interaction and benefit from that interaction in the implicit case, but they aren't learning that that's what they should be doing. And even if, you know, they might learn how to do it better because they're doing it and getting practice, but that might still not tell them that that's what they should do. And so they may not choose to do that in a future interaction. So I don't think that totally answers the question, because it isn't really addressing the issue of, you know, what does it take for you to internalize that scaffolding, which I think Frank Fisher's group has a lot more to say about than I do. You know, I'm not, I guess what I'm saying is I believe that there's something there. I think that probably in the long run, we do need to be able to fade the scaffolding. It makes sense that we would need to do that, but we don't have that all worked out yet.
Thanks so much, Carolyn. I've got one more from the chat, and then Simon Buckingham-Shum, I think, is going to ask a question live. The question from the chat is from Victoria, and she was just wondering, have you done or know of any studies of non-technical collaborative learning, for example, teams responsible for innovation, and if there's anything different about that context to the things that you spoke about so far?
Non-technical collaborative learning. So would that be like, well, so we did some collaborative activities around literature, so discussing readings that people had done, and that would be non-technical. And in that case, we were using the support to draw out the, you know, the reflection and interpretation of something that they read. And so I do think that it can be non-technical. We do tend to do a lot of our work in STEM just because we have the opportunity to do that research. I am hoping to get a study off the ground with Kylie Pepler at UC Irvine that's related to collaborative textiles. And there we're focusing on the idea of interdisciplinarity, actually. So yeah, I don't have time to talk in detail about that, I think, now. But I don't see a reason why the same principles wouldn't apply. I don't think the idea of transactivity has only been investigated in STEM. And they're based on its theoretical justification, it doesn't seem like it has to be applied in technical topics.
Great. Let me hand the mic over to Simon to squeeze a question in that hopefully you also have time to answer.
Okay, thanks very much. Hi, Caroline. Thanks for the talk. So you were very clear that, you're not pretending these agents are in any way super intelligent or human, and the students aren't meant to be trying to form any kind of relationship with them. But how do they regard them? Are there any sort of principles emerging about how you design the personas of these things so that students, well, what are you seeing in the way the students treat the agents?
Okay, so we've made a lot of observations over the years. I think actually the most important thing is that the students shouldn't regard the agents as getting in their way. If the agents seem like they're getting in the way, that's negative. If they like the agents and they focus on their interaction with the agent, it draws their attention away from the collaboration. And that's bad. And so we don't want to do that. We did have a study where we tried to get the students to like the agents more, because we thought then if the agents offered instruction along the way, they would be less likely to ignore it. But in that study, the intervention that we designed in order to make them like the agent more actually had more of an effect on how they treated each other than it did how they treated the agent. So then we didn't really pursue the trying to get them to like the agent more thing. We one time had a pair of agents, one of which was like more professorly and the other one which was supposed to be really dumb. And the hope was that the students would feel like, oh, I'm smarter than that student. So then they would have more confidence. But they just started to insult the agent, and that was also distracting. So my experience is that what we really want is for the agents to fade into the background. We don't want the students to like them too much or pay too much attention to them or think that they're like humans or think that they're super smart, because all they're really doing is offering a little bit of structuring and some little prompts here and there to kickstart an interaction between students. But what's really valuable in these collaborative learning encounters is the richness of the interaction between students, and that's our goal. So that's why we don't think it's that important to try to make the agents seem super sophisticated or superhuman. And so we don't do anything to try to do that. On the other hand, in a physical space, in order to not be totally ignored, you have to have some level of presence. And that's why we think that the gestures and the gaze is actually important, so that the students get the cue, oh, it's my turn. Oh, I should be listening now. And so there are subtle ways in which there's a little bit of intelligence that's important, but I definitely don't buy into the idea that, I'm an AI person and I have to make the superhuman, virtual human that's just like a person, and that's going to change the world.
Well, that's a perfect answer and a point to end on. Carolyn, there was one last question in the chat from Karsten, which was asking sort of what drives the agent's conversation, because one focus on mistakes might be sort of distracting and disturbing. And I think you've sort of said the goal isn't to do that. It's really to sort of, I think it sounds like a lot of procedural scaffolding as well as maybe some conceptual, but mostly kind of structuring the interactions. So I am going to end on time just because I know other people have places to go, I guess other Zoom rooms, no real places. And just to say thank you everyone for coming for these great questions. Thank you, Carolyn, for some exciting, engaging answers. This was really wonderful. I put the link in again, except it didn't quite work. But if you want to share suggestions for future speakers, or if you have also ideas about different ways to run the session, I really like that we had a bit of conversation at the end and got to see some faces, because while it may not matter for how Carolyn tracks collaboration, I think for some of us, it's just provides some nice human interaction we're all needing. So thank you again, Carolyn. Thanks everyone for coming. Stay safe, and we hope to see you all again very soon.